we need to be able to complete the square. So if we're looking at x squared, so sorry, part A again, x squared minus 7x plus 2. So completing the square, we know that we're halving the middle term, we're halving the b term. So x minus 7 over 2. Now leaving it as a fraction really will help us in a moment when we're looking to square it. So that all gets squared. Now, if we were to expand this bracket, we would get x squared, we would get our minus 7x that we want, but we would also get this term squared that we don't want. So we're going to subtract 7 over 2 all squared before adding on the 2 that we do want. So this is a very standard way of completing the square. Now, the reason I've left it as a fraction is because it's really then easy to square a fraction. So I've got this bit inside my bracket. I'm taking away 49 quarters and I'm adding on 2. And continuing really with what we need for core 1, we need to be able to do this fractional calculation here. So I'm going to rewrite 2 as 8 quarters. So I can see that this is x minus 7 over 2 all squared and minus 49 plus 8 minus 41 quarters. Now we could have done that differently. A lot of my students that did this exam found squaring 3.5 was quite tricky and they ended up with things like 9.25 and things that are just not quite right. So you either, if you keep it as a fraction, you won't make that mistake. Now part 2 says, hence find the minimum value of this function. Now if we're thinking about this quadratic itself, it has a minimum point. So the smallest value that this function can take is when x minus 7 over 2 squared is the smallest it can be, i.e. 0, because if you square a number, you're going to get either a positive number or 0. So the smallest x value is 7 over 2, and the smallest y value, i.e. when this thing here is equal to 0, is minus 41 fourths or 41 quarters. Now it doesn't ask for the minimum point, and if you put the minimum point, you don't get the mark here. It wants the minimum value. Now the minimum value is the smallest y value that the function can take, so that is minus 41 quarters. So they are two different things, the minimum point and the minimum value. Now finding the minimum point is not actually a waste of time in this question, because then we're asked to describe the geometric transformation. Now in order to find the geometric transformation, I think it's really useful to just draw a bit of a sketch to see what's going on. Now I'm just clearing some room here, but we're going to put the minimum point on our curve, or on an axis, sorry. So the minimum point is 7 over 2, which is sort of somewhere here, and a minus number here. So at the minute, that's our minimum point. 7 over 2, 3.5, and minus 41 quarters, which is minus 10.25. Now, we're looking for when it's going to be translated onto this graph. So this graph has got a minimum point of 4, 0. So the minimum point of this graph is 4 along, so a little bit further along here, but nothing up. So we're going there. So what we're being asked for is what moves a curve that looks something like that onto a curve that looks something like that. Now, because we know the minimum values, we're looking at how do we get from this set of coordinates to this set of coordinates here. So we are going to write down that it is a translation. So it's just a movement, it's not a stretch. And you must, to get all 3 marks, leave this as a vector. So what's happened in the x direction? Well, the x direction has moved positive a half, so 0.2, 0.5 or a half in the x direction. And the y direction has moved all the way up from minus 4, 41 quarters, all the way up to 0. And that is a positive movement. So it is the positive 41 over 4. And that's, for me, the easiest way to be able to do a question like this. Because we're using completed square form, we've got the minimum points of 2 different curves. How do we get from one to the other? Obviously, if we were trying to get from y equals 4 minus x squared back to the original curve, the this vector here would be negative in both directions because we'd have moved backwards and down. But as it is, we have moved forwards, we've moved along in the x direction, and we've moved up in the y direction.